Hello, hello. Greetings, groovy geographers. My name is Rachel Cunningham. I think I know most of you, but in case I don't, hello, I'm your professor for geography this semester. So this video is to walk you through a really short little demonstration of how to show numbers in maps. So you are watching this video because you are in one of my classes that talks about maps, their importance in everything we do, not just geography, but everything. And a common question is, because geography maps are a visual representation, how do you show numbers, which are often done through text? And so there are a series of different examples. This will help you to do your own exercises that I may have assigned you, or interpret some things that I may have assigned you as well. So let me go ahead and so we're going to be looking at a series of very specific types of maps that use different techniques for showing numbers. Depending on which class you're in or which exercise you're on, you may already know which one you are assigned to use for your exercise, or you might be able to pick from these options, depending on the question. So first, I'm going to go ahead and go through a list and a quick description of the most common types, and then we'll look at some examples and explain them. Okay? So the first one, excuse me, the first most common one, and one that probably all of you have seen before, is what's called a choropleth map. Choropleth map is one that uses various colors and shades to represent different quantities. These can be in full color, they can be in black and white, depending on what your budget is, vision color differences, and the psychology of what you're trying to show. And so the idea is that if you're using just one shade of something, you have a darker, more saturated shade to show something that has a higher quantity, and then a paler, less saturated shade to show something that has a less quantity. That's the most basic type of a choropleth map. You'll also see some that are like a spectrum. So it might have like red to like a beige to like a blue to show different temperatures or show different political stances, because reds and blues are often considered on opposite sides of the color spectrum. Again, the idea here is that you're using different shades and colors to show different amounts. You'll want to have a key showing you that like this shade of pink means 30 turtles, in this shade of beige means 5 turtles, or whatever it is that you're mapping. But a person should be able to quickly look at your map and be like, huh, dark color, that means more stuff. Okay, dot density maps are really used a lot in population type things. And so you'll be kind of counting very specific, maybe you're counting people or number of fish or number of trees or something. So dot density maps is where each dot on a map represents a certain number. You can do where each dot represents one. So every dot represents a sports bar in San Francisco. That's totally possible. But if you're doing something like each dot represents a tree, that would be totally impossible to map all the trees in California. So you might have like one dot represents 5,000 trees or something. Well, you still get the idea of the more dots means more trees, but you're not counting out thousands upon thousands of little trees. Proportional symbols is one that can show multiple types of data. Those of you who are in the lab course, this is what you'll be seeing in your, excuse me, in one of your atlas examples. So proportional symbol, the basic idea is the bigger the symbol, the bigger the amount, right? If I have a bigger square, that means I have more versus a smaller square. The nice thing about proportional symbols is if you're doing a pie chart, you can then add in additional information, which our example will have some of that. So if I have a really big circle, but then a tiny sliver, that might show that I have a lot of something, but only a tiny amount of some subset. So maybe I have a lot of giraffes, but only a few are the endangered. I don't know enough about giraffes to think of an endangered giraffe. Um, or so and so and so forth, right? Isolines is one that, again, if you are in one of my physical classes, you probably are already familiar with. These are used extensively in weather. and in topography. So you have a series of lines, you have a bunch of waves on your map. We see these in hiking maps, then also in a lot of weather maps. They're great for showing temperatures and for precipitation and for pressure. We have a series of lines going across and kind of a wavy pattern to show different numbers. Okay. I fixed it. Cartograms, these are not very practical. They're used to show, to make a point. They're very eye-catching. So a cartogram is going to be an intentional distortion of borders to show quantities. So you are like vastly distorting your image to make often a political point. Okay? So our first example would be a cartogram. And so you can see from this image, this is a pretty messy map. So this is the map of the world in proportion to population, and you might be thinking, wow, I don't know what half those countries mean. And so what this cartogram has done is they are mapping the shape of countries. So if you know the shape of Mexico or the shape of Italy, right? But they're using a grid pattern. You can kind of see all these little blue squares right here. They're using a grid pattern where every grid means a certain number of people. So it's using a bit of a dot density map strategy, but they're distorting the shape. And so looking at this, there is one country that is way larger on this map than it is in real life, and that would be India, right? The country of India is not this big. It's this blue one right here. But we know that India is one of the most populated countries in the world, so its size is distorted larger, right? Same for Philippines is not this large, but it has a large population, so the size has been distorted to look larger, right? The opposite of that would be poor Russia. Russia physically is an extremely large country, but population-wise, it is not. And the population that is there is all in the western side of the country. So this tiny yellow line represents all of Siberia, where not a lot of folks live. Same with Canada. Again, geographically, physically, a very large country, but population-wise, not a lot of folks living up in the very, very north portion of Canada. So it's been distorted to be just a single tiny line here. Okay. Again, cartograms, this is showing math. You are showing numbers. You could make conclusions about which countries have more populations, but it's not very practical because of the distortion. It's a nice way to catch your eye, the psychology of it, but you know, might not hold up in court kind of thing. This is an example of a proportional symbol map, and I've chosen one that specifically shows that pie chart effect I was talking about, which those of you in the lab class will see in your atlas. And so you can see this is looking at Olympic medals of Europe for some specific summer and winter Olympics. This symbol up here is going to be your legend. It's showing you the size of the shape means how many medals won. So you can say, okay, Portugal has a very small circle. They probably won between 1 and 5 versus Great Britain has a pretty large circle. They probably got between 51 and 100, right? So on the one hand, we're just doing the number of bigger circle equals more medals won. Then the additional data point that you can use for the proportional symbols, which is nice, is the pie chart effect. And so what this map is showing not just the number of medals, but what events they were in. So for example, you can look at Great Britain and Norway. Actually, Great Britain and Germany both have pretty large pie pieces. I would say these are probably roughly the same size. So, in comparison, Great Britain and Germany won roughly the same number of medals for these two Olympics. However, the colors in their pie chart are different. So, this orange color, which represents like rowing and sailing and kayaking, the kind of the water non-swimming sports, you can see that Great Britain's pie slice is bigger than Germany's, right? And way bigger than Russia's. So this tells you not just that, okay, Great Britain, Germany, and Russia all got kind of same range of medals, but the proportion that were in kayaking and rowing and sailing was way higher in Great Britain than it was in Russia. And of course, this is nice to say, like, obviously the purple being the skiing and snowboarding. Of course, Norway and Sweden got way more skiing and snowboarding than Spain, right? So you can show multiple data points here. The choropleth is, again, the most basic type of map showing numbers. If you've have any kind of atlas, this probably is going to have this. And this one here is just using the shades of this kind of purpley pinkish color. And so the darker the purple, the more the numbers. In this case, we're looking at cumulative confirmed COVID cases as of January 2025. And so you can very quickly look at this and say, which country is the darkest purple? And that would be the United States, which indeed does have the highest cumulative number of confirmed COVID cases. And so that purple sticks out, right? The nice thing about this particular color scheme that you've chosen is this would convert very nicely to a black and white or a grayscale. Again, color is expensive to print. People aren't going to be buying a lot of color magazines. Those are expensive, right? Also, if people have color vision differences, then you don't have to worry about, well, is it they're red and there's green and they look the same shade of gray. So this would be nice in that darker the color, the more COVID you got, the lighter the color, the less confirmed cases you have. And this is a great example, again, of making sure you read all of the data points given to you. Because at first glance, you might say, wow, Sub-Saharan Africa had no COVID. That's probably not true. The key here is it's the confirmed number of cases, which means you have to go to a doctor, take a test, have access to, medical professionals to actually give you a diagnosis, which in the United States, you could get them by mail order. I think Kaiser had like a drive-through nose swab. That might not be the case in parts of Sub-Saharan Africa where you have to walk many miles to get to a medical professional. Okay, but again, the idea of the color schematic is important here. And the last example I'm going to show you is a dot density map. And so this is showing firearm ownership in the United States. They got this from, I'm not sure where they got this data from, this person who made this. In this case, every dot represents 1,000 firearm owners, right? Instead of having one dot equals one firearm owner, there are 300 million people in the United States. That would be a lot of dots. So instead, every dot represents 1,000 people. The basics still gives you the idea of where there are more firearm owners than elsewhere. That also might be a function of population density in general. There are more people living in, New Jersey than living in, um, excuse me, Montana. But yeah, you're going to see things on the eastern seaboard, actually the entire East Coast, with the exception of Maine. Things on the East Coast are going to have a significantly higher number of firearm owners than, let's say, I guess this is Midwest. I think of this as more as Midwest, but I guess this is also Midwest. Um, and so again, every dot, the more dots, the more stuff you have. Okay, I hope that that was helpful. So again, you will either be picking one of these maps to use to map. Maybe you're doing your water quality lab or you're doing your horses lab or whatnot. Or maybe you already know which one you're doing and you'll be following us through there. Any questions? Drop me an email. Take care. Bye.